Hello everyone. Today I wanted to talk about thrust versus drag. My name is Marek Swoboda. I'm part of Amphi Americas, and when we present Amphi to people, I usually hear the question how fast Amphi can go. So I have jokingly answered, it's up to you. And today I wanted to explain what I mean. So for any swimmer in the water, you have two forces acting on the swimmer. One will be how much you are propelled, and this force is called thrust. And the second force, which opposes your movement, is called a drag. Now, what is interesting, the faster you go, the higher your drag. And it's described by this equation, where you can see that drag depends on the square of the velocity times the surface area projected, which is the surface area you create with your body, times a drag coefficient. Now, different shapes or the way how you configure your body will change this coefficient, will change the surface area you're exposing to water flow, and will also change the drag coefficient CD. Now, for different shapes, you see that we have different drag coefficients depending on the shape. So for a sphere, for example, we see that a drag coefficient is 0.47. For a short cylinder, the drag coefficient is 1.15. So you see that for the same surface area, a sphere will move easier through the water compared to a cylinder. For a cube, the drag coefficient is 1.05, so it's better than a short cylinder, but it's much worse than a sphere. If we have a streamlined body, like a submarine or a torpedo, then the drag coefficient is 0.04, very low. So it's almost 10 times lower than for a sphere. So you see that it's critical for you to create a very small surface area as well as very streamlined body shape. Now going back to the speed question. This equation is scaled by this factor, which is surface area times drag coefficient. So for different S times CD, you will get different functions. So this is drag, this is your speed. So you see that if you have a high S times CD, this function will go up very quickly. If your S times CD goes down, then this function will be spread and will go further to higher speeds. What it means for the relationship between thrust and drag. Let's say we have a constant thrust, and for people who have very high S times CD, those two lines will cross at very low speeds. It means that for the same thrust, you will have lower velocities. If you decrease your S times CD, your velocity will increase. If you do it further, your velocity will increase even further. So you see that it's up to you. So my answer is that if you streamline your body and your surface area is small, then for the same thrust, for a given thrust, you can go very fast. If you have a lot of gear on you, if you don't care about streamlining, then for the same thrust, same propeller, you will go slower. So that's our Whiteboard Monday, and see you next week. Thank you very much.